Hello everyone, in this class we are going to discuss the problem on some del operator and some other problems on position vector R. Okay, now look at the first problem. Prove that del cross del pi equal to 0. Okay, where pi is a scalar function. Okay. When I apply the del, first del on pi, it should be gradient, not a dive. Why? Here pi is a scalar function. Okay, now first apply this del, next this del. Okay, now del pi, I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. Now next del cross del pi. Now cross product I j k. Now first this del we have components I dou by dou x, dou by dou y, dou by dou z. For digital pi, components are dou pi by dou x, dou pi by dou y, dou pi by dou z. Now find the determinant I into, now here dou square pi by dou y dou x minus here dou square pi by dou y dou x, same terms, right? Minus j times now dou square pi by dou x dou z minus dou square pi by dou x dou z, same term. Okay, plus k into now dou square pi by dou x dou y minus dou square pi by dou x dou y, same term. Simply they are cancelled. There is 0 0, this term 0, let cancel, this term 0 this term 0. Now 0i plus 0k, j plus 0k equal to 0 vector. Here prove 0. Okay, now second problem. Find div R, curl R, where R is a position vector. A position vector, then simply in a 3D plane, any point can have for x comma y comma z. Okay, position vector we have xi plus yj plus zk. Okay, now that is a R bar. Okay, now first find div R. Div R bar equal to div nothing but del dot R bar. Okay, now del is I dou by dou x plus j dou by dou y plus k dou by dou z. R bar is xi plus yj plus zk. Okay, now dou by dou x of this is 1, I dot I 1, dou by dou x into x is derivative of x with respect to x is 1 plus y with respect to y is 1 plus z with respect to z is 1. 1 plus 1 will equal to 3. Next curl R bar. Now curl R bar equal to del cross R bar I j k dou by dou x dou by dou y dou by dou z x y z. Now I into z with respect to y is 0 minus y with respect to z is 0 minus j into now z with respect to x is 0 minus here x with respect to z is 0 plus k into this row cancel. Now with respect to y 0 minus with respect to x with respect to y is 0. Okay, here y with respect to x, here x with respect to y is 0 0. Now simply 0. Now next third problem. Okay, now third one, find del dot 1 by r del r power n. Okay, now before going to solve these two problems, we need to know some of the relations. Okay, R bar is a vector, xi plus yj plus zk is a position vector. Now mod R, magnitude of this is root of x square plus y square plus z square. Now these also we represent with R. R nothing but magnitude, R bar nothing but position vector. That we need to remember it. Okay, some of the books they written R as a capital R also. కొన్ని books ఇక్కడ they represent with the capital R also, but R bar is a position vector, R is a magnitude. That we need to remember it. Okay, now what is R square? Now x square plus y square plus z square. Okay, now this we derive it with respect to x. R r derivative to r. In r we have x, y, z terms, that's why dou r by dou x equal to, here with respect to x derivative, then is 2x remaining 0. Okay, here 2 cancel. Now dou r by dou x is x by r, x by r. Now similarly, when you derive it with respect to y, 2r dou r by dou y equal to 2y. Okay, now dou r by dou y equal to 2 cancel. This r IDT on this side. Now y by r. Now similarly with respect to z derivative, now 2r dou r by dou z equal to z, 2 cancel, dou r by dou z equal to z by r. Okay. Now first part, look at the first one. Okay, del 1 by r. Del, okay, here not a r bar, r is a scalar quantity. Okay, r is a scalar quantity, but r bar is a vector. Okay. Now del 1 by r. Now nothing but del r inverse. Okay, now this r inverse to apply for each term. Now I dou by dou x of r inverse plus j dou by dou y of r inverse plus k dou by dou z of r inverse. Instead of writing of these three, you can write for only single term to using of sigma. But I here wrote three terms. Okay, next problem I am going to write for sigma, better to understood some simplest form. Okay, now here r inverse derivative is minus 1 by r square into that r derivative dou r by dou x plus j into again r inverse derivative minus 1 by r square into dou r by dou y here. Okay, now here r inverse 1 minus 1 by r square again dou r by dou z. Now dou r by dou x is x by r, dou r by dou y is y by r, dou r by dou z is z by r. This we are going to apply here to get this one. Now I dou 1 minus 1 by r square into x by r plus j minus 1 by r square into y by r plus k 1 minus 1 by r square into z by r. Okay. Now here 1 minus 1 by r cube minus 1 by r cube minus 1 by r cube, that I common it, remaining xi plus yj plus zk. Okay. Now minus also I come. Now minus. Now this is r bar, right? Now this is representing the position vector r bar. Now minus r bar by r cube is a solution. Now second one, del r power n. Now r is root of x square plus y square plus z square, right? Now r power n is x square plus y square plus z square whole power 1 by power n, nothing but n by 2. Okay. Now on this we can apply the del. Now del operator. Now apply the del operator. We should have this, you have to apply for each term. Each term. Instead of writing for each term, the little big term we obtain. For that I use for a sigma. Now this term for only x. After getting the simplest form, this I split into the y term and z term. Okay. Now only I write for here only x term. I use a sigma. Now this sigma for x, y, z terms. Okay. Now this is only x. Now after getting a simplest form, that I explain split to the y and z. Okay. Now this derivative with respect to x. Now x whole power n by 2 we have. Okay. Now that n by 2 into whole power n by 2 minus 1 into this term derivative is 2x. Y square z square is 0. No need to write it. Now n by 2 we have in each term. In x term we have, in y term we have, in z term, that n by 2 write it outside. Now this term r power n by 2. This is we have r square, right? X square plus y square plus z square is r square. Now r square power n by 2 minus 1. Okay. Now these two also we have for each term. This is a common. These terms are common for each x term, y term, z term. Now non-common term is ix. For second term we have iy. For third term we have iz. Okay. So kz. Okay, that we are going to apply. The common term wrote here. Now first term xi plus second term yj plus third term zk. Okay. Now here 2 cancel. Now this LCM it n by 2 by 2. But this power 2 is cancelled. Now this is a position vector r bar. Now total we have n r power n by 2 minus r bar. If you understood here, okay. Now the other method to solve this. Okay, now look at that. Del r power n, same problem, second method. Del r power n sigma I dou by dou x of r power n. Okay, now this I use for sigma, simplest form. Okay, now r power n derivative into r power n minus 1 dou x dou r by dou x. Dou r by dou x just we find for is x by r. Okay, now r power becomes n r power n minus 2. Okay, n r power n minus 2 by r. Now for this term we have xi. When you split these, we have xi plus yj plus zk. Now this is r bar. Like this also can do the problem. Okay. Now next class I am going to discuss this problem. The prove that del square r power n equal to n into n plus 1 r power n minus 2. And other problem we have here, show that del square f of r equal to f double dash of r plus 2 by r into f dash of. Okay, these two problems I am going to discuss for the next class. Thank you.